So far we have discussed about indefinite integrals. Now we talk about definite integrals. So here you will realize later on definite integral is mainly based on indefinite integrals only. So if I have integral fx dx, you know that this is called indefinite integral. Indefinite integral. It's not unique, you know. One function may have several integrals. That's why it is sometimes called indefinite integral. But if I have a suppose continuous function, let f be a continuous function. There is a continuous function on say closed interval ab here, on closed interval ab. Then we write like this here, integral a to b fx dx. This is called definite integral. This is called definite integral. Definite integral. This is read as integral a to b fx dx. Here a is called sometimes lower limit and b is called upper limit. This is sometimes called lower limit. This is called the lower limit of the integral, and this b is called upper limit of the integral. Upper limit of the integral. Upper limit, lower limit. You will see that the value of definite integral, the value of definite integral is always a number, remember. Is always a number that you will see there. In indefinite integral, the value was function always. Answer was in x or t or theta. Here, the value of definite integral is always a number, remember. It may be positive, negative. It depends upon the function which we have chosen. But in general, here, this definite integral, that is integral a to b. Suppose if I just give a small idea here. There's a xy here. Suppose there is a graph of function. This function y is equal to fx here. If I consider here x equals to a as this vertical line here, and x equals to b this vertical line. So now this is the region. This region is bounded by this x-axis here. Function y is equal to fx, line x equals to a and x equals to b. This region has area, and this area of this region here, this area of this region, that is a, which is given by this definite integral a to b fx dx, remember. And you know area is always a number. So answer of this one is always number. It's unique, and that's why that's called the definite integral. So this represents the area of some region, remember. This might be negative also. Here I have written a number. So to get the area we can put here modulus, remember. So in case if this is for example -2, then because of that modulus become +2. So like this. But basically this definite integral represent area of this, you can see that bounded region, this region. Okay, so with this information, let's define here definite integral. So here definition is based on indefinite integral only. So if we know indefinite integral of fx equals to, let's say, capital Fx plus c, this much you know, this is called indefinite integral. Then definite integral a to b of the function fx is given by, in this function instead of x you put upper limit first, so f of b minus, instead of x you put the lower limit. This is answer. This is the definite integral. So here what you have noticed, that this definite integral is mainly based on what? Indefinite integral. You need to know what is the indefinite integral of the given function. Here this sometimes also denoted by this symbol. You write indefinite integral plus c, then in here we write a and here we write b. Then in this expression instead of x you put b, minus instead of x you put a. C will get cancelled, that you will see even once we do some examples. This is the only definition, remember. You get indefinite integral first, then in indefinite integral instead of x you put upper limit, minus instead of x you put the lower limit. This can be proved, remember. This is sometimes called fundamental principle of definite integral, remember. This is called here fundamental principle or fundamental theorem of integral calculus, remember, which we'll see later on. But here as a simple example, suppose I want to integrate 0 to 1 x dx. So what I'll do, I'll write indefinite integral here. What is indefinite integral? X square by 2 plus c, and then I'll write here box and 0 to 1. Now what's the definition? Instead of x you put upper limit, in place of x you put upper limit here. So whenever I have x, I'll put 1. So 1 by 2 plus c, minus instead of x you put lower limit, that is 0 plus c. So you can see that c will get cancelled, that is just 1 by 2. So this is the definite integral, remember. If I just illustrate here what this says, if you consider here, you know that fx equals to x is a straight line through origin. It would be like this. X equals to 0, lower limit. X equals to 0 means this, y-axis, you know. X equals to 1 here, upper limit, remember. X equals to 1 is such line, you know. This is x equals to 1. So you can see that there is a triangle between 0 and 1 with this function. This is fx equals to x function. This is the x-axis. So this triangle. What this half represent, that is the area of this triangle, remember. You can verify the area of this triangle. If you find directly, this is a right angle triangle. So using half base into height, if you do, again you will get the half only, you can verify. The area, that is half base. Base you can say it is 1 unit. Height also 1 unit. So here also you are getting 1. And this we did by right angle triangle, but this half basically represent the area of this region triangle. That's what we mean by definite integral. So remember, definite integral always represent the area of certain region. That region need not be triangle, need not be square, it can be anything, remember. Fine. This is just for your information, remember. Up to this we have to do the in integral. This is just I've shown for your information. Okay, one more example. Let's see. Suppose I want to integrate. Let's write integral 0 to pi by 2. Let's write cos square x. So you need to keep basically indefinite integral in your mind, remember. How do we integrate cos square? You know, you need to use double angle formula. 0 to pi by 2, 1 plus cosine 2x the whole by 2. You know it, if you remember points to remember. Double angle formula. Keep half as it is outside. What is the integral of 1x? What's the integral of cos 2x? It is sine 2x by 2, and limits are from 0 to pi by 2. Integral of 1 is x. Integral of cos 2x is sine 2x upon the coefficient of x, which is 2. Now limits 0 to pi by 2. So in this expression, if you want, you can write plus c, but it will cancel anyway. You can see in the previous example. Here you can see c you can cancel here. So no need to write c. If you write, doesn't make any difference. Okay. Now instead of x, you put upper limit first. So here pi by 2. If I put here pi by 2, that inner 2 will get cancelled, and it is just sine pi. Sine pi is 0. Minus lower limit. Here this is 0, sine 0 is 0. So finally you are getting pi by 4. This is the required integral. So definite integral of cos square from 0 to pi by 2 is pi by 4. Fine. Now I'll just state two results which are based on definite integral. The one is integral a to b. If you have fx plus gx, then like indefinite integral you can do individual. So integral a to b fx plus integral a to b gx dx. One is this integral a to b fx dx plus integral a to b gx dx. You can split into two integrals if you have addition. Same way, if you have subtraction, again you can consider it into two integrals, remember. And if you have constant, that you can keep it outside. Integral a to b k into fx dx. So that constant will come out as we did in definite integral. Integral a to b fx dx, where k is some constant, you know. The constant you can take outside the integral. If you have plus or minus, you can take integral inside. Okay. Third, integral a to b, if you write, of fx dx, and if I write integral a to b ft dt, then both will be same, because here variable is not important, because finally you are going to place the value of variable. You can see it just depends upon the limit. So integral over the variable x or over the variable t, both are always equal. The variables are not important in definite integral. And one more, if you change the limit integral a to b fx dx, if I just write b to a, then you have minus sign of fx dx. If you change the limits, then it would differ by minus sign. Remember, here you have minus sign. And finally, one more point here, integral from a to a, integral from a to a of function. Now a to a means there is no region, so definite integral has to be 0. Because here what you will get, if you just go back to definition, here you will get the f of a minus f of a, which will be 0. A to a if you are having, then here f of a minus f of a, which will be obviously 0. So here this is 0, remember. If you change the limits a to b, b to a, then integral would differ by minus sign. Whether you write variable x or variable t, integral remains same. And for plus or minus, you can take integral inside, and constant you can take it outside. With this information, we go to here next exercise, which is 7.9. It is purely based on indefinite integral. Okay, so exercise 7.9. I'll do some of the questions because you know the procedure here. It is just based on, remember, indefinite integral. Integral minus 1 to 1 x plus 1 dx. So what we do? We integrate it. We write upper limit minus lower limit. Finished. You just need to recall indefinite integral. What's the integral of this? X square by 2. What is the integral of 1? X. And limits are from where to where? Minus 1 to 1. Now instead of x you put 1. So here 1 by 2 plus 1 minus, instead of x you put minus 1. So 1 by 2 minus 1. 1 by 2 plus 1, here 1 by 2 minus 1. Now you can see that this half and this half will get cancelled, so final value will be 2. Right? The only this much is new for you, remember, this much you know, this is indefinite integral. Okay, question number 2, integral 2 to 3 1 upon x dx. You know integral of 1 upon x, log of mod of x. You can write plus c if you want, but that's not important. Limits from 2 to 3. First upper limit. So here log 3 plus c minus, instead of x you put 2. Log 2 plus c. So c will goes away. You know log of x minus log y, that is log of x by y plus c. Oh sorry, c will not be there, I'm sorry, we have this much only. Here plus c won't be there in definite integral. Answer will be a number, remember. Okay, I'll go to fourth question. Integral 0 to pi by 4 sine 2x dx. You know integral of sine. What's integral of sine? That is minus cosine. This is linear function, remember, upon the coefficient of x. And what are the limits? 0 to pi by 4. Linear function upon the coefficient of x. If you want, you can keep minus 1 by 2 outside. Now first upper limit, pi by 4 here. So this is 2 into cos pi by 4, which is cos pi by 2, so 0. And if I put 0 here, cos 0 is 1. So this is just half, remember. Question number 7. Integral 0 to pi by 4 10x dx. You recall integral of 10. What's the integral of 10? You know it is log of mod of sec x plus c. If you want, you can write here. And limits are from where to where? 0 to pi by 4. Now what's the next step? Upper limit minus lower limit. So here this is log of mod of sec pi by 4. C will goes away, minus lower limit. So here log of mod of sec 0. This is nothing but, you know, here root 2 minus this is 1, sec 0 is 1, and you know that log 1 is 0. This much you know now. What is log 1? That's 0. You know it. Okay. So here this is raised to 1 by 2, and 2 I'll take into the product. So half log 2. That's the value of this integral. Okay. Next I'll go to ninth question. I'm just doing some of the questions because this is purely based on, you know, indefinite integral 1 upon x squared dx. What is this? Prepared formula. This is nothing but the sine inverse x, you know. Derivative of sine inverse x is this plus c. Remember here your constant first. If it is like this, x square minus 1, then it would be in form of log, if you remember, log of mod of x plus something. But here your constant first, 0 to 1. Okay, put upper limit first. So sine inverse 1, c will goes away, minus sine inverse 0. What is sine inverse 1? You know pi by 2, because sine pi by 2 is 1 and sine 0 is 0. So answer is pi by 2 number. Next, I'll go to question number 13 here. In 13th question, you have integral from 2 to 3 x upon x square plus 1. You must have realized this is which form? Linear upon quadratic, remember. You did now number of questions. So once you write the question, you must have idea it is which standard form. Linear upon quadratic. What is the derivative of this one? You know 2x. So I need to set 2x here. So you know procedure, multiply and dividing by 2. So 2x upon x square plus 1. Now this is which standard form? F dash upon f. This is which standard form? F dash upon f. This is f and this is f dash. So what's the integral recalled here? 1 upon 2 as it is. What's the integral of this one? Log of mod of denominator function. This one, log of mod of fx plus c. And limits are from where to where? 2 to 3. So first upper limit. So 1 upon 2 as it is. Here log, first upper limit, 9 plus 1, which is log 10. C will goes away. Minus log 4 plus 1, which is 5. And finally, this is not log 5 minus 5, therefore log 5. Remember here log a minus log b. So here log 10 by 5, which is 2, and this half is already there, remember. So half into log 2. Why log 2? Log of 5 by 2. 5 by 2 gives us what? Log 2. So here in 13th question, the answer is 1 by 2 log 2. Question number 14 here. integral 0 to 1 2x plus 3 upon 5x square plus 1. So it is which standard form? Again linear upon quadratic. So we set the derivative of denominator function. What's the derivative of 5x square plus 1? It is 10x. So I'll set there. I need 10 here. So multiplying dividing by 5. Integral 0 to 1 10x plus 15 upon 5x square plus 1. Now what we do? We split into two integrals. If you remember linear upon quadratic forms, we are just repeating that. Remember 1 upon 5, we split into two integrals 0 to 1, this upon this, 10x upon 5x square plus 1. Here 1 upon 5, that 15 you can take outside, so 15 by 5, integral 0 to 1 upon 1 plus 5x square dx. Now this can be integrated very easily because this is f dash, this is f. So what's the answer to this? 1 upon 5 log of mode of denominator expression 5x square plus 1. Limits are from where to where? 0 to 1. 15 by 5, which is just 3. How do we integrate this? This is the standard formula, you know, x square plus a square. How do I rewrite this? This I write root 5x the whole square. So then it becomes this formula, x square plus a square. What is that? 1 upon a tan inverse x by a, if you remember. This is the formula. Just I'm reminding you the formula. So here 3. What about this? 1 upon a. 1 upon a means 1 here. Into tan inverse x by a. That is root 5 x by a, which is 1. Here remember coefficient of x is root 5. So upon root 5. So I need to write upon root 5 here. Coefficient of x upon root 5, and then limits are from 0 to 1. So this is indefinite integral. Now definite integral will come into the power. So upper limit minus lower limit. Just put the upper limit 1 by 5 as it is here, upper limit. So here 1. So this is log 6, 5 plus 1. Minus, you put 0 here. Log 1, which is 0. Okay. Plus 3 by root 5 as it is. First upper limit. What is the upper limit? That is x equals to 1. Tan inverse root 5. Minus, you put 0. Tan inverse 0 is 0 here. So here the final value is 1 by 5. If I write one more step here, 1 by 5 into log 6 plus 3 by root 5 into tan inverse root 5. Okay. Next here, let me go to question number, for example, 18. Question number 18. Integral 0 to pi sine square x by 2 minus cos square x by 2. Right. You must have noticed this is the standard formula. What is this? Function is known to you. Directly you cannot integrate here. 0 to pi. You know cos square minus sine square is cos 2x. So I'll take minus common. So it becomes just double of this, which is cos x. Cos square minus sine square. Minus. Now what's the integral of cos? That's sin x. Sin x, and limits are from 0 to pi. So here minus sin pi is 0, sin 0 is 0. So here answer will be 0. The value of definite integral here is nothing but 0, remember. Let me do the question number 15. So here you know that this is not linear. So e raised to linear is not there, so it cannot be integrated directly. So what you need to do, the only way to do is x square equals to t, substitution. Once you do the substitution, you need to differentiate x square 2x derivative of t with respect to x dt by dx. Now this much is already present, you see, x dx. So here what is x dx? That is nothing but the half dt. So here x dx is half dt. So here 1 upon 2 outside, this is dt, and this is e raised to t. I'm doing as indefinite, yet I have not placed the limit, remember. What's the integral of e raised to t? E raised to t plus c. Now I'll place the value of t, that is half e raised to x square plus c, and now I'll apply the limit here, remember, because I've converted in x. The limits are about variable x, remember. Here you cannot write 0 to 1. So 0 to 1. Now upper limit minus lower limit. First 0, e raised to 0, first 1, e raised to 1 is e, plus c will get cancelled. Minus here 0, so e raised to 0 is 1, so half e minus 1, that is the answer, remember. In the question number 15, that is half e minus 1 inside the bracket, remember, in the question number 15. Now we go to next question, which is, let me do question number 19. I'll be doing 19 now. That is integral 0 to 2 6x plus 3 upon x square plus 4. Linear upon quadratic, you need to set the derivative of this. What's the derivative of this one? 2x. I need to set 2x only. So to set 2 here, I'll take 3 outside. So integral 0 to 2, if I take 3 outside, this is 2x plus 1 upon x square plus 4. Just taking 2 outside from this. Sorry, 3 outside from this. Why I've taken 3 outside? Because I need just 2x. Okay, now split into two integrals, 0 to 2, 2x upon x square plus 4. This is f dash upon f form. Plus 3 is common for both. Integral 0 to 1 upon 0 to 2, 1 upon x squared plus 4 is 2 squared. This is a known formula. What's the integral of the first one? Log of mode of x square plus 4. Log of mode of denominator function. Limits are from 0 to 2. Plus here 3 as it is. If you remember, this is a known formula. 1 upon a, that is 1 by 2. Tan inverse x by a, that is x by 2. And limits are from when to a? 0 to 2. Now put upper limit minus lower limit at both the places. So you will get the final answer. Last MCQ 22, let me do it for you. Integral 0 to 2 by 3, 1 upon 4 plus 9x squared dx. So it is again this formula, remember, x squared plus a squared. So I'll just rewrite like this, 0 to 2 by 3. This is 2 squared plus 3x the whole square dx. Now this is which formula? 1 upon x squared plus a squared. So you recall it is 1 upon a. 1 upon a means 1 upon 2. Tan inverse x by a. X means 3x. This is your x by a. Don't forget to write upon 3, because here this linear 3x you have considered as x upon the coefficient of x, which is, I'll write here 1 by 3. And what are the limits here? 0 to 2 by 3. I hope you must have understood this now. So 1 upon 6, first upper limit, I'll put 2 by 3. So this is just tan inverse 1. What is tan inverse 1? Pi by 4. Put 0. So this is just 0. So the final answer is pi by 6 4s are 24. Pi by 24. So C is your correct option there.